All right, guys. So we are going to talk more about similarity today. Kind of in one triangle, kind of with some parallel lines, kind of in two triangles, sometimes just a lot of different similarity or proportionality that we can write. So we're going to label this parts of similar triangles plus extras, because there's that's another reason for me that this chapter is a little bit hairy, because there's lots of proportionality that we can find. It can also be written in a lot of different ways because fractions can be reciprocated. So it can be a little extra. So we'll do that on 69 and 70. I think in this video we'll do page 70, and then in a second video we'll do page 69. Okay, so starting here, first our triangle proportionality theorem says that if I have a parallel line to a side inside of a triangle, then we talked about this a little bit last chapter where, you might have that mid-segment thing where you have that parallel line to the other one, but that one was connecting midpoint to midpoint, so it was like right in the middle. If it's not right in the middle, but it's still parallel, you can still get this proportionality, okay, where we can travel along the edges, like I kind of have drawn here, but you can also go side to side like this. So we can write it as BC over CD. Okay, so as I travel along the parallel line, this side to this side, and then instead of doing the whole triangle to the whole triangle, like we were doing with similar triangles, you can just use this little part down here from this quadrilateral shape and say that this side to that side is proportional. So AB to DE. Okay, so it's kind of like, we pick a portion of the side of the triangle and we go along the parallel line to get the other, and then same thing down here. Now, like I was saying before, this is kind of like our triangle mid-segment theorem that we talked about last chapter, but that's if it's right in the middle. So the mid-segment connects the midpoints of the two triangle. We would have this is equal to that, and this is equal to that. So we can also see there how they would be proportional to one another, because if I write this over that, it's the same as the top one over the top one. But also the mid-segment is half the length of that last side. So that's what we were doing before, where we could say that AE is double the smaller one, or we can take half of AE and it's equal to the smaller one. So either one. I usually like to double because then I don't have to deal with the decimal potentially. Okay. So if we open this guy up and try the top here, let's just go through the mid-segment stuff really fast because that was something we already did. So if it's right in the middle, like this guy is here, then it's just half as much. So x would be 5. And if I need to go the other way, then we just double it. So 7.5 times 2, or 7.5 doubled, is 15. We can also do that here. So oh my gosh, sorry. I blanked out for a second. I need to take half, so 3.5. And then lastly, we're going from small to big, so we got a double. So x is 12. Oh my gosh, I totally had a brain fart there. That was, anyway. Over here, if it's not talking about that mid-segment compared to the parallel side, if we're talking instead kind of about the transversals or the other sides of the triangles, then the proportionality that we get here is where we go along the parallel line and we can write those ratios. So I can write 4 over 5 is the same as x over 5, which means, I can cross multiply and solve here, but I think I can also just see x is 4. Okay. Another way to do this one here is if we go straight across this one here, we got 3 over 9 is the same as 6 over x, because I got to travel in the same direction. Then we can cross multiply and solve, or like I can see that here I divided by 2, so, well, or here I times by 2, that's a better way to think about it, times by 2 to get that. So I'd have to times by 2 to get this. So x would be 18. Okay, this one here, if I don't know, let's instead start here for funsies. So if we travel along the parallel line this way, we got x plus 6 over 10 is the same as traveling this way, so x over 2. Now I could do this one like, okay, I see from 2 to 10 is times by 5, so I could do that here, but maybe that's a little weird because they're both x's. So we can always fall back on cross multiply, so we'd have 10x equals 2x plus 12. I would subtract the 2x both sides, so 8x equals 12. And then divide the 8, which I can reduce there, so we'd get that x equals 3 over 2, or 1.5. Okay, so again, it's all about, like, if I have these parallel lines, I can travel along the parallel line and write side to side ratios. So x plus 2 over 18 is the same as x minus 1 over 10. And that one's less obvious. And again, because I have double x's, I'm probably just going to cross multiply here. So 18x minus 18 equals 10x plus 20. I would subtract the 10, so 8x, and add the 18, so 38. And then divide the 8 and reduce to get that x is, sorry, I ran 2 goes into both, 19 over 4 times. Bang-a-ring. There you go. Okay. Now again, down here, we can do a lot of proportionality in triangles, but also just like with parallel lines. So if we have these parallel lines, there's lots of different ways that we can travel to write some ratios. So one that you can do is AB over CD. Actually, let's get a little color going on here. So if I do AB over CD, what I did was travel along the transversal in the same directions. So like both of them were going down. So travel the transversal piece by piece. Okay, so like A to B, C to D, we went in the same direction. You could also go like B to A, D to C, going up the transversal. So just travel the transversal piece by piece, like each piece of the line. Another way that you could write a ratio here, or proportion here, is to do A over C equals B over D. So that's kind of like what we were doing in these triangle ones above, where I'm traveling along the parallel line in the same direction. Okay, so AC, BD. So travel the parallel lines piece by piece. Okay, so do. Or you could write like CA over DB. You can go the other way because it's reciprocated, so it's kind of the same. And then the last one you can do that's kind of weird as well is you can do A over A plus B equals C over C plus D. Now this is really only one of many possible combinations for this one, but what we did there is we went like A over the whole thing, and then c over the whole thing. So again, you're traveling along the transversal, but it's like piece to the whole. So you can do that with all these really too, where it's a piece to the whole when you're traveling along the transversal. So like this one up here. So when I travel the transversal, you can do piece to whole. So again, what I mean by that is a piece of the line to the whole line, where I have to add up, or I could have done a piece of the line to the whole thing. So lots of different options there, which again, just makes this kind of hairy. Okay, so let's try some. So I could do piece to the whole. That's kind of making it more complicated than I need it to be. I could also travel along the transversal. There's lots of different ways we could go about that. Actually, with this one, that's kind of simple. Let's show you two ways. So one of the ways we talked about was traveling the transversal. So if I travel the transversal like this, that's one way I can solve for x here. So first way. I'm not going to do them all two ways, but I do want to show you guys how you can do multiple ways. So travel the transversal piece by piece. So I could do 10 over x equals 16 over x plus 4. Cross multiply and solve. So we'd have 16x equals 10x plus 40. Subtract the 10. So 6x equals 40. Divide the 6. So x reduces to 20 over 3. Yeah, 20 over 3. Okay, so another way that I could do it, instead of traveling the transversal, I can travel the parallel lines piece by piece. So if I travel the parallel lines and maybe I go this way, that's a second way to do it, but I should get the same answer. And that's why I really want to show you at least one of these multiple ways so that you feel good about kind of writing the fraction how you want. So if we travel along the parallel line piece by piece, we'd have 16 over 10 equals x plus 4 over x. So here to here, here to here. And cross multiply and solve. So we get 10x plus 40 equals 16x. And I mean, I can go through the rest of it, but this equation right here I can already see is going to be the same. So we end up still with 20 over 3. Okay. Now, again, I could do piece to the whole, but that just seems like it's making it more complicated than it needs to be. So let's do this one. I don't know. Let's go parallel lines. We'll go this way. Oop, I used the wrong color. Eek. If we travel along the parallel lines, I was using pink for that, so we'll do that. Okay, so traveling along the parallel lines, we'd have 2x over 8 equals 6x over x plus 4. Now, the reason I kind of chose to do it that way is I noticed right here I could reduce a little bit. You can do that. So maybe I'll do that, and then I'll cross multiply. So I'll have x over 4. Now, I can't reduce here because there's an addition sign. So if ever there's addition or subtraction going on, you can't divide. But this was just multiply, so that's why I could do that. Then we'll cross multiply, so we'll have 24x equals, x times x, which is x squared, x times 4, which is 4x. Oh my goodness, it's been a minute since we've seen an x squared thing. So this is stuff from last year. That was kind of towards the end of the year, which maybe means that you kind of don't remember it a little bit because it's when we went on quarantine the first time. But if you have an x squared and an x, you have what's called a quadratic. When there's just an x, it's just a linear. And if you're trying to solve a quadratic, you need to make it equal to 0. So I would actually subtract the 24x here. And if I rewrite this problem over here now, I would have 0 equals x squared minus 20x. And then the best way to solve a quadratic is to factor. And so if I factor, I take out what these two numbers have in common, and they both have an x in common. And I'd have x minus 20 left, like if I undistribute almost. And then you set each thing equal to 0, like each parenthesis. So I have x equals 0 from that first x. And I have x minus 20 equals 0. And then I can solve for x. Like I already know it's 0, but, well, it can't be because 2 times 0 will make that line 0. And that's not legit. So over here I add the 20. So that must mean that x is 20 because that will actually work geometrically. So you'll get 2 answers with a quadratic, but they probably both won't work. Like one of them might make it 0 or might make it negative, which means it's not okay. And guys, I wouldn't stress too much about this, but it's so fun, right? Okay, let's look over here. Oh, yuck. Oh, I was like, what the heck? Like if I write a ratio here, like I can't because there's 2 different letters, but I didn't even realize I put those little tick markies there. So I can really solve and say 2a equals 4a minus 1 because they are, like it says so. And so I'd subtract the 4a and get negative 2a equals negative 1. So a is half. And then I could plug it in and know exactly how long the line is. But, I mean, if these 2 parts are equal, so are those, right? Because they're all proportional. So if these are equal to each other, so will those be. So we can just say that x plus 3 equals 2x minus 1. And like I'm not even using one of my proportionality things. So that's, again, just another reason that this can get a little hairy. And then I'd add the 1. So we'd have 4 equals x. And a is half. And then this last one here, let's try traveling the transversal. So if I travel the transversal and write those ratios, I'd have x plus 2 over 3x equals 4 over x plus 4. So again, I would cross multiply. So 12x. Ooh, another fun thing. On this side over here, I got to do x plus 2 times x plus 4. And I don't know if you remember, but you got to do like FOIL is probably how your algebra teachers taught it to you, like first, outer, inner, last, like where I multiply first times first, outer numbers, inner numbers, and then the last numbers. And so when you do that, you end up with a quadratic again, like we were over here. So we have x times x for x squared, 4x, 2x, and 8. And then we can combine like terms. So we'd have 6x plus 8. And then, like on this last one, I need to make it equal to 0. So I'd have to subtract that 12x. And we'd have x squared minus 6x plus 8 equals 0. Now on that last one, I was able to like basically just undistribute and I was done. These don't have anything in common. So that's where factoring really comes in. And we had to think, what multiplies to 8? Like which 2 numbers will multiply to 8? And those same 2 numbers will add to negative 6. And so I'm pretty sure negative 4 and negative 2 will multiply to a positive 8 and add to a negative 6. And so we wrote it like this. Like we foiled it out up here, but then we unfoiled it or factored it back over here. And setting each of those equal to 0 will get me that x is 4 and also x is 2. And this time I think they can both be true because if I plug it here, it's 6 and that's fine. And if I plug it here, it's 2 and that's fine. So they're both an answer, even though I just said that weirder things have happened. So guys, I know this is a lot because you have a lot of options, and the options are all good. Just be consistent, right? Either travel the transversal and write your ratio, or travel the parallel line and write your ratio. We don't often do piece to the whole unless they just give me the whole line, because that just makes it more complicated. Okay, good luck.